Hi, our group name is Stranger Things. The people working on this project are Neerad, Jruvika, Ritika, and Rashmil. Our project is topic summarization. It involves accumulating a tweet corpus and then extracting topics from it. We'll start with a quick run through of the UI of our web application. We have a simple home screen with a search bar. The user enters a query. Let's search for the word Christmas. On pressing enter, we are presented with a list of cards. Each card represents a topic in the tweet corpus. The topic summary can be seen on the card. There is also one extra topic named assorted containing all those tweets which could not be categorized under any one particular topic. It should be noted that only those topics which have relevant tweets for the query are shown to the user. To see this, let's now search for the word ridicule. As you can see, only one topic has tweets relevant to this, apart from the assorted topic, of course. The user can now drill down into the topic to see the tweets. You also have the option to go back to the summary page. This is a quick run through of our UI. We now move to the algorithms used for topic extraction. The first approach involved hierarchical clustering. For reference, we have taken the 2014 research paper on event detection in Twitter. The gist of our implementation is as follows. We start with simple spam filtering. We consider only those tweets which satisfy the following criteria. The tweet should have at least 4 words. The number of hashtags and user mentions in the tweet should each be less than 4. A larger number is indicative of a spam tweet. This leaves us with a tweet corpus containing tweets which hopefully hold good information. A document term matrix is then generated. The terms are bigrams and trigrams. With this term vector representation of each tweet, we first compute pairwise cosine distances between all the tweets in the corpus. Agglomerative hierarchical clustering is then done based on these distances which were computed. In this step, each tweet is initially considered a cluster on its own. In the first step, the two closest clusters are combined into one. We are now left with n-1 clusters if we had initially started with n clusters. So this process is repeated n times until we get one big cluster that includes all the tweets. This was implemented using the Python package sklearn. This now leaves us with a dendrogram, which is essentially a tree diagram that contains the cluster information at each step of the clustering process. We cut the dendrogram so that we get 10 clusters, which translates to 10 topics. Finally, we want to generate a summary for each cluster. To do this, we compute the centroid tweet in the cluster and then find that document which is closest to the centroid. This would give the best representation of the cluster and would be chosen as the summary. However, we make a slight tweak in the centroid calculation. We boost those terms in the cluster vocabulary which have named entities. An example of a named entity is the word Christmas. This boosting moves the centroid more towards documents that contain named entities. The reasoning behind this is that we obtain more news-like topics when we give more weight to named entities, which in turn leads to better topic summary generation. To identify named entities, the CMU part of speech tagger was used. This tool has been trained on tweets and thus promises more accuracy than the more generic NLTK package. This was our first approach. The second approach we tried was latent Dirichlet allocation based topic tagging. The initial spam filtering steps were in common with the earlier approach. Each tweet is then represented in the bag of words model. An LDA model is then extracted from this representation of each tweet in the entire corpus. The Python package gensim was used for this implementation. In an attempt to get more accurate results, we ran many passes over the entire corpus, since that would lead to better topic convergence. The results, however, were vague. On observation, the clustering of documents into topics was not consistent. The reason behind this could be the short and noisy nature of tweets. In theory, the data sparsity of short documents is what causes the problems. LDA relies on statistical inference to discover topics. It models each document as a mixture of topics, and each word in the document is taken from a topic. The performance of this is proportional to the number of words in each document. Given a very short document, it becomes difficult to infer the topics that make up a document. Hard approaches to clustering, like the vector space model based hierarchical clustering, in their naive implementations, seem to offer better results than soft approaches like LDA when the corpus has documents of short length. And that's it. Thanks for hearing us out.